This is the 9.7 homework, problem number 2. So we're looking at Janet Swifteagle, who wants to purchase at least 20 minutes of computer time. She needs at least 7 minutes of time for computer A, etc. You're capable of reading it yourself, so let's just start. So looking at this, first, our two variables are time from computer A and time from computer B. So let's define X as being the number of minutes for computer A, and Y as the number of minutes for computer B. Let's look at the time constraint. So it looks like she wants to purchase at least 20 minutes of computer time total, meaning X plus Y is greater than or equal to 20, because it's 20 or more. If we turn this into an equation, we'll want a graph. If we subtract x from each side, we have y is greater than or equal to 20 minus x. Slope-intercept form, let's make it y is greater than or equal to negative x plus 20. Now let's look at the real world constraints, RW for real world. First, we know she needs at least 7 minutes of time for computer A. So that's x is greater than or equal to 7, at least. And then she'll be able to rent computer A only if she can rent computer B for at least 5 minutes. So then Y is greater than or equal to 5, because again, at least is that much or more. And then as far as our cost equation, computer A, $500 per minute, so that's 500 times X, and or plus $200 per minute for computer B, which is Y. Okay, let's graph. So first, let's graph this time constraint. Y is greater than or equal to negative x plus 20. Y-intercept of 20, slope of negative 1. Go all the way down. You can make as many dots as you want, or you can use a ruler. I can't use one easily on here, so I'm just going to make a bunch of points myself. And then we'll try that again. That's a terrible line. Let's try again to make a graph. There's our line. And then we have x is greater than or equal to 7. So here's where x is 7. And y is greater than or equal to 5. Here's where y is 5. And let's continue those lines. So it's easy enough to see where x is greater than or equal to 7 and y is greater than or equal to 5 is. But let's test a point for y is greater than or equal to negative x plus 20. So let's test 0, 0. And then 0 would be greater than or equal to negative 0, which is just 0 plus 20. Is 0 greater than or equal to 20? Nope. So that means we are actually going to shade not on this side of the line, not on that side of the line, but on the other side of the line. And in order for it to be x to be greater than 7, has to be that way. In order for y to be greater than or equal to 5, has to be above there. Okay? So now we have points to look at. We have this point here, which is 7, 13. And this point here, which is 15, 5. Now let's find our cost. For 7, 13, so x is 7, y is 13. 500x plus 200y is 500 times 7 plus 200 times 13, which is 6,100. The cost for 15, 5 xy is 500 times 15 plus 200 times 5 equals 8,500. And now we want to minimize our cost. So we'll look at what's smaller, 6,100 or 8,500. 6,100. So then, to minimize the total cost, Janet should buy 7 hours on computer A and 13 hours on computer